Okay, we are now on day 2 of the exam review, okay? So you'll be happy to know this is a lot less math calculation involved here. A lot of it's just vocabulary and it's very visual for the most part. So we're going to cover attributes and transformations of quadratic functions. Complete the questions for each graph. What is the vertex? The vertex is always the very top or very bottom of a parabola, right? So here's my vertex. And what's the ordered pair? It's 1, 4. Since it's at the very top, it is a maximum, okay? The line of symmetry always goes right through the vertex. It's a straight up and down vertical line, and it's always x equals, because x equal lines are always the vertical ones, and it's always that number, the x value of the vertex. So this line of symmetry equation is x equals 1. What are the roots? The roots, as I showed you on the last video on the calculator screen, it's where the parabola crosses the x-axis. They're also known as solutions. They're also known as zeros, and they are also known as x-intercepts. It's all the same thing, okay? What are they here? -1 and +3. Now you could write it 3 ways. You could write -1, 0 as an ordered pair, +3, 0. You could just write it as -1, 3, because we know the y values are 0 if we're talking about roots, right? You could even say x is equal to -1 and x is equal to 3. Be familiar with all the ways because it's anything goes. These are all valid ways of writing it. Just understand we're talking about those points. Okay? That's all you have there. Let's take a look at number 2. Again, we have a vertex. Let's find it. Oh, there it is, the very bottom this time. The ordered pair for that is -1, -2, 4, 5. -1, -5. This is not a maximum. This is a minimum because it's at the very bottom. Line of symmetry, again, goes right through the middle of the parabola and through the vertex. The equation is x equals -1 this time, right? Okay, what are the zeros? Again, they're right here and here. I'm just going to list them one way. I'm not going to do all 3 ways this time. We could do -3, or x equals -3. The other one is +1. All right? Let's go ahead and take a look at number 3. I'll fold the paper so we can get a little bit better picture of that one. All right, we have, oh, sorry, I need to read the directions. Identify the attributes of the quadratic function and draw the parabola with the axis of symmetry. Now, honestly, you can graph it. You can sketch it from the calculator screen. I'll show you that right now. In fact, let me leave this not zoomed in so I can put the calculator right beside it. So I'm going to type in my equation, x squared minus 2x plus 3, x squared minus 2x plus 3, right? Okay, there's my parabola. Now, I like turning on the grid lines. Menu 223 on most calculators. That tells me right there, 1 to the right and 2 up. That looks like my vertex, right? And then so on and so on. But you can get an exact sketch by going to your table. The vertex should be the only y value that doesn't have another same y value. For example, I have 3 and 3 here. I don't have a 2 and another 2 somewhere else, right? I have 6 here and 6 here. So I already thought that 1, 2 is the vertex. And since that's 2 is a single y value, there's not another 2 on here, I know it is the very lowest point. Okay, so 1, 2 is my vertex. I'm going to plot it, 1, 2. Okay, the axis of symmetry is going to be x equals 1 because it goes through the vertex. I'm going to go ahead and just pick out some points here, 0, 3, and 2, 3. Let's pick out a couple of other points. -1, 6, and +3, 6. Now I have a good sketch of my parabola, and it's accurate. It has actual points that are right off the table. Okay, the y-intercept, it looks like it's right here, right? The y-intercept is where x is 0. 0, 3 is my y-intercept. So that's how you do those. All right. Number 4. Once again, we're going to do the same thing. We're going to put it in the calculator. We can get all the stuff we need. So I go to my graph. I have y equals negative x squared minus 4x. So negative x squared minus 4x. There's my parabola. Turn on my grid. Menu 2, 2, 3. Looks like the vertex is negative 2, positive 4. Verify it in the table. Go to negative 2. There it is. And notice the 4 is the only y value of 4 that we have. We have a 3 and a 3 above it. We have a 0 and a 0, right? 4 is the only y value that doesn't have a twin y value. So negative 2, 4 is my vertex. All right. Let's graph a few more. We have negative 3, 3 and negative 1, 3. And then I have negative 4, 0 and 0, 0. That's a good sketch for my parabola, right? My axis of symmetry is, since my vertex is negative 2, 4, my axis of symmetry is x equals negative 2. My vertex is 2, 4. The y-intercept is 0, 0. It crosses the x and the y-intercept at that place. So that is number 4. Let's take a look at number 5. This time it says draw and describe the transformation. Okay? Now you can graph both of them. I'm going to graph y equals x squared. That's the parent function. I can sketch that pretty well. Okay, let's go ahead and sketch it. So I'm going to go ahead. I have my table here. Give me some values. I have negative 1, 1, positive 1, 1, negative 2, 4, positive 2, 4, right? So that's a decent sketch of the parent function, which is what that is. Now I'm going to tab and type in 4x squared minus 3. So you should know when you add a number on the end, if it's a positive, it goes up. Since this is negative, it's going to shift down 3. And that number in front is going to make it skinnier. Let's watch and see. It did shift down 3, and it did get skinnier. That's what they're talking about. Describe the transformation. Okay. Technically, you could just get it from your calculator and write it down. I'll do this one on the sketch, but on the second one, I'm not even going to sketch it. I'm just going to do it in the calculator and show you. And you can write it down. So this one, it went down 3. And it goes through here, it looks like. Pretty close, at least. And it goes, let's find some y values that it goes to. 0, negative 3. We got that one, sorry. And then the next one's not till 13. So it goes way off. It doesn't hit right at a grid box intersection until it gets up to 13, so it's too high. So that's a little sketch. Not a very good one, but I have a box here. I can't move my hand over because I'm recording on top of this box. So, in short, the main thing we're looking for is you recognizing what happened. What happened? It got narrower and it shifted or translated down 3. Okay, let's go ahead and look at number 6. Again, we have the parent function. I already graphed that one. It's the blue one. So I'm not going to delete it. I'm going to keep that one. But I'm going to change this red one to my new one. 0.25x squared. 0.25 x squared. Okay? It got wider. It did not translate up or down. It stayed right there at the origin, but it got wider. There you go. Okay, on the next video, we will cover the next section of that.